So today we're going to review the climate change unit. Hopefully for homework last class, you would have gotten together all of your unit tests from the year so that you can go through them and see where your mistakes were, and printed off the chemistry unit test review and worked on some practice questions after we reviewed chemistry last class. So this class we're going to be working through the climate change unit, and then for homework will be to make sure that you've printed off a blank copy of the climate change review package and work through those questions with this sheet for practice. So firstly, weather versus climate, the difference between the two. So an example of weather would be something specific to a place and time. So for example, it's 27 degrees and sunny in Lakefield. And then if you want to give a definition as well, you can put in that it's a specific and local forecast. Versus climate is more of an average pattern over a long period of time. So, for example, it's hot and dry in the summer in the US, in the Midwest, so like Texas and things like that. So we can give an example: hot, dry summer. Summers in US Midwest. Or, deserts are hot and dry. Rainforests are humid and damp. Okay, so an average, the definition here, average, pattern, over time. The next thing we're going to look at is albedo. So albedo is the percent of incoming radiation that is reflected by Earth's surface. So the radiation from the sun comes in, and so albedo is how much gets reflected back out. So we're going to put a little definition over here. So albedo is the percent incoming radiation the surface reflects. So some examples of things with high albedo, which means that lots of the light is reflected, are things that are going to be light colored. So snow, ice, sand, versus some examples of things that have low albedo are darker in color. So that would be things like forests and open water, so things like oceans and stuff like that. So the average albedo of the entire Earth is about 30%. So most of the light gets absorbed because we have a lot of open ocean and things like that. But it changes slightly with the seasons. Think about winter. It's going to increase a little bit because there's so much snow and ice. So more light is going to be reflected. But in the summer, there's less, so more light is absorbed. So we'll just put a note in here. So Earth's average is about 30% gets reflected, but we'll make a note that that can change with the seasons. Okay, next we're going to look at just a quick overview of what the greenhouse effect is, what greenhouse gases are and how the light comes in from the sun to warm the earth. So here we've got the sun, and light from the sun comes in and it's going to hit our atmosphere. So our atmosphere is represented by this cloud piece here, and it contains molecules that are what we call greenhouse gases, which means that they insulate like a blanket the earth. So N2O, nitrous oxide, CO2, carbon dioxide, CH4, methane, and H2O is water. So those are some examples. So here we have the incoming solar radiation. We can label that. Comes in, these represent our greenhouse gases. And what happens as they come through is they become infrared radiation, which is a form of heat. So heat then gets trapped in this sort of blanket space to warm the earth. So this is trapped infrared radiation. So the natural greenhouse effect is a good thing. If we didn't have it, then water wouldn't be able to exist as solids, liquids, and gases, and we wouldn't have any life on Earth the way that we know it. And it keeps our Earth at a good enough, warm enough global temperature on average that life can be sustained. So we'll make a couple notes here. Natural greenhouse effect, which is sort of represented here by this picture. Okay, so the atmosphere traps enough heat to keep the average global temperature at 14 degrees Celsius. And this is necessary for life as we know it. So I'll make maybe a little note here. Water in all 3 states. Versus the anthropogenic greenhouse effect. So remember, anthropogenic, that word means human caused. If you want to add a note here so we can remember that definition. Human caused. So human activities increase the amount of greenhouse gases in the atmosphere, which then traps more heat, so that the average global temperature begins to increase. And we call this also the enhanced greenhouse effect because we're making this stronger or amplifying it. So human activities increase the amount of greenhouse gases trapping heat. Okay, and this leads to increased average global temperature. Also known as the enhanced greenhouse effect. All right, so let's talk a little bit more about all the different